Hello everyone and welcome to Handmade Hero Show, where we code a complete game live on stream. We currently need to add some things to our visualization in order to track down a bug I believe we can still trigger in our collision detector. I can't quite remember last week if we were still able to trigger it reliably, but I'm pretty sure we were. I'm pretty sure it's like you go up here, and you right at this intersection here. We've turned off all of the textures on the walls and stuff, so they're just like the blue outlines right now of the collision geometry. And if I throw that glove up in the corner like that, my recollection is that you could get into a situation where it will tunnel. You know what I mean? So it'll like tunnel through, and I'm totally failing to do it, but there was a bug here, or at least I thought there was. And I don't remember if maybe like we ended up in a situation where we can't really reproduce it very well because we fixed something. But I thought we could still do it, and then what I was saying is that in order to find it, because it's very like hard to debug something like that without some way of being able to like sort of step through it and see what happens, the idea was going to be we need to do something where we where we like can single step through things. So I was like, what I'll do is I'll single step through it. Now, why I cannot redo it, I'm not sure. Like I said, I have so much stuff to do during the week, I forget usually like where I left off on doing stuff in Handmade Hero. So it could be that we changing the way that the embedding code worked makes it so that this doesn't happen anymore or something. But I could have sworn that we at least had, I remember saying, I'm like, next week we'll have to do this. It's been 2 weeks. So I give myself a little bit more of a pass. But the fact that I can't make it happen is sort of depressing. So that's unfortunate. I'm not sure what to do about that. I thought, and maybe I'm wrong about that, but I thought that we were still having that. And maybe we're not. Okay, so at least we're still having this one. There we go. So if I walk backwards through here, you can see it getting stuck in there. So, hey, I've got something I can debug anyway, which is all we really care about as far as like putting together the system. So what you could kind of see happening here, right? There's a few things that are going on. To be honest, I'm not 100% certain. I think what we did is we have a thing in there that stops the recording whenever whenever it triggers a case where, yeah, I remember this now. It stops the recording whenever you end up in a case where you find yourself colliding on all 4 points or something like that, or more, or all eight, where you find yourself embedded. It stops recording or something like that. I don't remember the exact specifics, but like we can go in and look at the code, and that should not be happening. Like in these situations, as far as I know, we probably shouldn't have that happen. Now, I don't know if that's actually true because oh wait, no, I do. I was gonna say, because there's like the head on the guy that could push us in. That's what we did. We removed the head collider. So when we move through the world, the glove can move anywhere it wants. The glove is basically unconstrained right now. There's nothing forcing it into like a bad position or anything like that, right? So the fact that it can get stuck doesn't make any sense, right? It shouldn't be able to end up in a situation where it gets in that case like that, right? It should not be able to do that because the fact that it can do that means that it somehow has a like it somehow left itself in a cell that when it ended it thought that cell was open, meaning it was a cell that could be moved through. But when it started the next frame, it thought the cell could not be moved through. Now, it's worth noting, and this is a very creepy coincidence, so it suggests that maybe this is also implicated in it. You may have noticed that why is this drawing, I'll make this full screen. Why is this drawing over here? Right? Doesn't make a lot of sense, does it? Well, you have to remember that we did the extra work in the engine for this game, which is, just because I was trying to show, like, interesting things that you might want to do if you program. We did the extra work in this game necessary to make it so that there's no bounds on the world size. So basically, like, you can make the game be, as large as you want. And in order to facilitate that, we made it so that the camera itself only moves in a very small range of floating point values. And we just map the world into that local range so that the floating point values work. Right? So that operation, every time you cross a boundary, it like recenters the camera. And so when you see that happen, that is because the camera recentered to a new location, which is here. And in doing so, it's still drawing this because these are recorded in just a debug recorder. The debug recorder doesn't know where they are. It knows just where they are relative to the camera. So the reason that this is very troubling is because you'll notice that the glove only seems to get stuck when the camera moves like that, right? The two places it gets stuck are the two times, right, that you have the camera recenter. Now, when the camera recenters, it is true that the floating point consistency will be slightly off. Because since everything's relative location is to one center, which is the previous camera origin, and then on the next frame, everything is updated to be relative to a different camera center, which is the new camera origin, the floating point computations from the first one will not match the floating point computations from the second one. So it is theoretically possible, that you could have the exact correct placement of something such that when you change the camera center, something that was just floating point rounding away, right, from being considered embedding, suddenly isn't floating point rounding away from being embedded. That's entirely possible, right? That's entirely possible. However, the reason that I'm not even a little bit, without further investigation, willing to say that that's what's going on here is because it would be really strange if literally, like, both doorways that we happen to walk through at the beginning of the game both had that exact crazy floating point rounding scenario happen when you walk through them every time. Right? It doesn't seem super plausible to me that that could be what's going on. So I'm worried that there's some more severe problem that has to do with camera recentering that is causing a much more likely to occur failure of that kind. And that is why I would like to investigate this. Because a floating point error of the kind that I just discussed is not something you would expect to happen very often. It's one of those, like, rare cases, So I'm worried. I think we have a more serious problem, and that is really what I'd like to investigate. And the fact that I can't reproduce the other bug, we could go back and watch the video from 2 weeks ago. It might be that, like, this was just an embedding bug problem that we fixed because we had like not had the embedding code turned on properly or whatever it is. So maybe that's just not maybe that just can't be reproduced now. Like maybe that bug is basically gone. I'm not sure. So I'm willing to give up on reproducing that one temporarily. Maybe we can go watch the video later and see if that's what we did. But in general, yeah, I would say seems reasonable. Seems reasonable. You know, that reminds me, 644, I should double check before we start programming. Did we check in last week? I'm so busy these days, I have no idea what's going on most of the time. But I want to make sure we checked in the latest one, code base. Yeah, 643. So that's all good. 643 and 644. So I think that's it. That's really all. I just want ways of polishing up this collision detector, and I feel like I just need a way to step through this better if I'm going to be able to do that. It's a bummer that this happens to only occur at that recentering point, and the reason that that's a bit of a bummer is because that means that the drawing of it will be kind of wonky, like it'll have to draw in a different place. That's okay because I guess we don't really care, but it's still like kind of, that's too bad, right? It's the worst case for us for debug viewing because we don't track the location of things like that. We could try, and the way we would do that is that when we call recenter, we would also call recenter on the debug drawing, and maybe that's worth doing. There's like a call that we call here, right? And, you know, this nonsense tells us what we're going to do for moving the camera stuff around, right? And so you can see here there's like the camera target P and the camera P are updated via this function. Inside the world mode, when we call update camera for entity movement, which is here, you can see that there's like already a little stuff that updates like a few things, just like, oh, you should place it relative to this or whatever it is, right? So, you know, we could do a thing where we just pass like into the diagramming system, we just like pass a thing that will update stuff based on this change. And I mean, maybe that's worth it. If you look at the diagramming system, it wouldn't be very difficult to do. You know, if you imagine just a thing that's like this, where you say like, hey, offset the debug diagrams, where you can update them or whatever. In fact, I think it should be like probably like this. If you have something like this and you just pass in an offset to like, you know, whatever it's going to be, we should be able to do something like this where we loop through all these guys. And by the way, if you see what's happening here, one of the things that's kind of annoying, this is why like unions are not the best thing sometimes, is if these had just been expanded, you could basically just do this in a polymorphic kind of way automatically, right? The fact that it's a union means we do have to check to make sure that it's something that actually has like points in it. You know what I'm saying? Like one of these things. And to be honest, I forget what overlay was even supposed to be. I don't know if overlay doesn't really have any parameters, so I think it's just these. So it's not the end of the world, but you can see why, you know, sometimes it's easier if you don't use a union. It's just a quick case of whether you're trying to keep things like compact or not. But basically, like, you wouldn't have to do this switch. You would just offset the points if you weren't doing this. Right? But it's still really easy, so it's not worth getting you know, upset about. But, you know, it's just an example of something to be aware of. So in this case, we don't have anything to do. In the default case, there's nothing, so we don't have to. But if we did have other things that we wanted to change offsets of, we would. So that's it. And now all we have to do is go and actually call this with some offset variable that will move the things to where we need them to go. So it would be something like this, where we said, like, you know, all right, the old blah is something, the new blah is something. I don't know whether the target P or the regular P are the things that we want here, but I assume it's target P, not camera location. Because the camera location just can move all around or whatever, right? So I'm assuming that when we do our, like, our simulation center, I guess it's just this, right? If we wanted to look at the difference between those two things, we could just, like, actually check and do that update. I think, because all of these things happen first, that actually, like, you know, we might want to just do it this way, where we just go up here and say, when we are going to actually, like, when we actually start the frame, that's when we would do the offset based on whatever we are going to set the camera placement to. So like right here where we do like the camera transform or whatever we're going to do, it might actually be here that makes more sense for that. Probably. Yeah. Yeah. So that's my guess, and we may already have the information that we need. I'm not sure. But we may already have the information. So if we look at, like, game camera, we're keeping one of those, right? And we may already have a thing that says where it was last time. I don't actually know. But, like, we have to do this for the lighting already. Excuse me. Like, when you look at Lighting Center, we have to do this already. It may be that we keep that in the lighting system, but you can see why I'm like, yeah. You would imagine that this would just be something, yeah, like, so you see how, like, there's information here about the origin. My assumption is that we just, like, probably kept that in the lighting system, but, you know, here. So you can see, like, this last origin P here is kept inside the lighting system. So it's kind of like a duplicate piece of work if I keep it in two places. So it kind of feels like we don't really want to do that. But I don't know. It depends how you look at it, whether you want to unify those or not. But what you can see is this test right here is doing exactly what we were just suggesting. We take, like, the lighting and we move it based on when the camera changes, and you can see it, you know, just proceeds from there after having done an offset, and then it just keeps going. So, you know, do we want to do that? Do we want to do that? I'm not sure. for now, I think I might just say maybe systems do this themselves to avoid people getting out of sync in like calls. So, you know, here's another thought. Maybe we actually just roll this into a offset that everyone uses. So like, for example, what we could do is say that at the top of the frame, we tell you what the simulation center is. Like this. And then maybe it just does this itself. So like there's, in the diagram system, there's just like a call. You know what I mean? And maybe this goes away. So there's like a set origin thing, and it takes like a world position. That's the origin, and the offset is like it will compute it, you know? So I think I like this a little bit better. That, I think, has a higher chance of working reliably. So, like, if you imagine in here, we're just like, all right, you know, there's, you know, one of these things, and we just do, like, if they're not equal, we just update, and the offset is just like subtract the movement that we need to get ourselves between these two. I have to think about this. I always have to think about this. I'm bad at these sorts of things. I oftentimes get it wrong. Oops. I oftentimes get it wrong here. Nice job. Let's try that again. So if I want these things to be relative to the new origin, right? So I've got things around an origin A, and I'm going to a new origin B. Then it means that I need to take... Yeah, I should just do this out longhand. This is where computer-aided algebra should just be built into editors. But, you know, doesn't matter. Anyway, so, you know, I've got something like the origin A plus the offset, right? And it is needs to be equal to origin B plus the new offset, right? Maybe I'll use U and V. So V is the new offset, U is the old offset, right? And I need these two things to be equal. So A plus the new offset and B plus the old offset have to be in the same place. I think that's roughly what we're trying to do here. So if I need to now solve for like what this value is, right? I need to subtract this over to the other side, right? So I need A like minus B plus U equals V or whatever, right? So A minus B is the value that I would want to add to the old one. And so it is subtracting the new origin, which is the opposite of what you would normally think. So unless I screwed that up, that's why I say I often get this wrong. Like, you know, my guess was the wrong way around, which is exactly, I guess you could say my guess was right in the sense that I guessed that this was wrong. So you want to subtract the old origin from the new. You want to subtract the new origin from the old origin. So you want it to look like that, which is the opposite of what you would do if you weren't trying to recenter, right? So that's why it's a little bit, you know, it's a little bit swingy. Now that all that said, I may just have done it wrong because, like I said, it's always wrong. We'll know pretty quickly because things will not work. But that's my first guess, right? Okay, so it looks like world position is not known at the time that the diagram system is included or something like that. Which is true, right? You can see it here. So, yeah. The one thing I would say is this probably doesn't need to be out here anyway. So we could also just do this. And that would probably be fine. All right. So we do need the diagram's CPP file, though. That does need to be moved down below, like, the world code, because otherwise we wouldn't be able to do any of that. I don't know. Maybe there isn't one of those. Let me see. Maybe I'm wrong about that. Maybe I don't have to do that. Yeah, okay. So I guess I don't have to do that. There just isn't an R equal for those. We'll take a look at that in a second. Let's take a look at subtract. So we will need the world here, right, which I guess makes sense because it needs the dimensions of things. So the only thing we don't have here is an R equals. We have R in the same chunk, which I suppose is good enough in this situation, maybe, but it's not really what I want. So it's weird that we don't have one that checks for exact equivalence. So I suppose that's okay. It's not. It's not maybe quite right. So I don't love that, but I guess that's just how it is sometimes. Okay. So diagram set origin needs to take the worlds, but other than that, it's fine. And wow. All right. So that wasn't very good. Oh, right. So that is just because these are, some of them use these as a radius, right? So we do have a slightly different thing that happens here. The sphere uses that one as a radius. Not sure if there are any other gotchas there. So let's try that again. So yeah, like, see, I am again wrong. So I wonder why my math was wrong on that. Probably because I didn't think it through quite right. About what was actually, like, the math probably wasn't wrong, but the setup for the equation was wrong, right? So why was this math wrong? First, let's make sure that it actually was math wrong, because flipping the sign of this would, if I was just wrong about the setup, would produce the correct result then. But it may be that this is wrong too. So it may be that I'm just doing something completely wrong, period. In which case, the math was the least of our concerns. Still seems wrong. Like, I don't know what that's supposedly doing. Okay, so maybe this is just wrong in another way, and we don't have to worry about the math part of it just yet. All right. So I'm not sure why this would be incorrect, because it looks roughly like what we want, right? If we have origins that move, we just need to update ourselves for those origins by looping over the diagrams that have already been included in the system for previous frames, basically, and change what they're relative to so that they're now relative to the new center, right? That seems relatively uncontroversial to me. I don't understand why that wouldn't work. It's possible that we're producing the wrong offset here, but I can't immediately see what else we would be doing. One of the two ways of having that go should have produced the right result, and then we could have worked through the math of like why which one is correct or not correct. But since neither one does, it means that something's wrong structurally, right? Like this is just wrong in general. And I'm not sure how that result came about. So, yeah, I'm not sure why that seems like it should have been pretty straightforward, but I guess it wasn't. So, shows you what I know. Not much. So the top of each frame, we set the origin to the simulation center that is going to be used to produce the stuff, and that's where everyone will do their relative submissions from here on. So it seems like that should be relatively straightforward. The simulation center itself doesn't really move other than in hops, right? Like it moves like clunk, clunk, clunk. So it only happens every so often. And so most of the time, this is going to be 0. And then on certain frames when it changes, it's going to be something non-zero when the origin changes. And then it does this thing. The chunk part, I don't know if maybe that part is wrong, which seems like it could sort of be. I don't know. Subtracting the new center from the old center is almost certainly correct. I'm pretty sure our math was right. So I'm pretty sure that this is actually what we want. And it did a very counterintuitive thing. So let me look at what it looked like again when we did the thing that I thought was correct, because I want to understand that a little bit better. You can see that it like hops, it like moved the thing back here somehow. And I do not know how. Right? Like that is very confusing. The simulation center went forward by not really even that amount. Like that doesn't seem, maybe that was a simulation center delta. I mean, maybe it was. Because it would have been like, the simulation center would have been like something like here. And then the simulation center would have been like something like here, probably. Right? It's hard to say. But like, if you look, it's, I don't know, somewhere like there. So, I mean, I guess I could believe that that was the amount. And so if you look at what's happening, that move, it offset it by an amount. It's almost as if it's still using the same offset from what it was before. but having done the offset for the new center. It's almost like it didn't update the new center, but is offsetting it properly. I suppose maybe that would be what happens if you offset by twice the amount that you thought you should offset by or something, but I don't know how we would produce that because we don't multiply any of these things in that way. If we ran this twice, it should not do it twice because this would stop that from happening, right? So in other words, once you get the old origin set, you won't do it again. So how did that happen? How? How? The question is how. So I guess the thing about Simulation Center is, you know, in theory anyway, I think, in theory, the Simulation Center I should also check all these p-values, which is what I'm doing right now, but I believe they're all, yeah. All these p-values are correct. Yeah. So I don't get it. I do not understand why this would be causing a problem. It's very strange. So I suppose what I'll do is I'll step through and I'll look at to make sure these change when I think they change. We'll start there, just in case I'm like totally wrong about that. Which is easy to do when you only program on something every once in a very long time, right? It's pretty easy to make that be wrong. So like, yeah, if we go, let me just go into the diagram code, I guess, and just set a breakpoint on when this happens. So in here, like, okay. So we should see it hit this breakpoint one time, which is at startup, right? When it first goes to render the world, presumably it would hit that. Okay, so the fact that it doesn't hit that breakpoint, unless Remedy just isn't setting the breakpoint properly or something, that seems really weird, right? Because what are the chances that the last origin P was already the cleared to 0 last origin P was already the origin P? Is it just because we do happen to start literally at 0? That would be cool, but weird. So let me just check the first time we call in here, and see what those values are, because now I'm just like, what? So that's what we would expect, right? It's uninitialized. Okay. So I guess this is okay. It really is the R equals thing. When I was like, this doesn't look right, it's not right. So we have to do the R equals thing. Okay. I mean, good to know. So the other thing we could do here is say, look, if these two things don't produce an exact value, we could do this. You know what I'm saying? So like if they're not correct. So that was it. I think that was the entirety of that. Completely explained what we were seeing. So we can move on to seeing if there are other problems with it. Okay. Let's try again. And now we're good. Perfect. So I think that was worth doing. Didn't take very long, and would have taken a lot less time if I had actually had an R equals call. It would have called it, and that it would have worked. But hey, doesn't matter. Anyway, so as you can see, we're still doing the thing in the collision routine where if it hits that case, it stops recording the diagrams, which is what we want, so that we can step through them and see how we got into that case. And as you can see now, you can see what I'm talking about. There's just too much. Like, this is just a record of everything that happened over several frames. It's way too much to be able to see what's going on. So even though all of the information we need to understand the bug better is in this diagram, we can't make meaningful sense of it because there's just so much garbage, we can't see it. So that's why I said we just now need to make this thing actually work, where I can turn on like single stepping and then have like some controls here that let me like scrub, right? So I can just say like move, right? And then move or whatever, right? So I just need to add something like that, which actually shouldn't be that hard to do. It's just a little bit of busy work. And what you can see is we've already set up like the part of the code that we haven't actually been using, but it's this whole begin end part. We already set up diagrams to do this. They already have begin and end like around relevant sections. So if you look at like the code in question, like move entity, it already has like an underscore begin. Oops. So we should be able, because there's a begin on each stack walk and in the refine and over the entire thing, we should be able to make something that just like hops along those begins and ends, like without much trouble. So like we don't really need to do any additional work to like figure out what we should be viewing for single stepping, because we already like we knew when we started this that we wanted something like that. So it shouldn't be particularly difficult for us to actually make that happen now, right? I also, there's a couple of things I'm not entirely sure about. Like we had some text stuff in here, and I don't know if we ever actually... Yeah, so I guess we kind of did... So we haven't, there's a couple other things we haven't done, like do we want to like put the text up there and anything like that? We may not need to do that. We may need to, I don't know. But anyway, so if we just have like the diagram and begin and end stuff, what we can do here is probably just make it so that we keep some kind of a counter. So we have a like, you know, diagram index or something like this. And it's a little bit more complicated because we kind of need like a stack for it, where we will, as we do begins, we have to track like which one we're on at each level, because these things can be nested and we may want to be able to like drill down or up or whatever. And that just seems like the most straightforward way to do it. So we'd have something, you know, like this or whatever. And when we go through here, whenever we do a diagram begin, we would increment the diagram depth, right? And whenever we do a diagram end, we'd decrement it, you know? And when we hit a begin, we would increase the diagram index at the depth that we're currently at, right? So if we're at nothing, and we hit a begin, we increment the diagram index for the 0th depth, but then we update the depth plus 1 so that now any begins, if we hit a begin, it's like a sub-diagram, right? It's at a lower depth. Or whatever. We know that we can't do anything about it if the diagram depth is not, is outside of what we track. So we're sort of pre-saying, like, look, I don't know how deep these things go, but not very deep, right? Like, you can't just stack diagrams inside diagrams inside diagrams infinitely, because I don't even know what good that would do anyone. 1 or 2 levels deep is going to be the most that you could ever really use effectively, because otherwise it would take you so long to navigate, right? But then, once we're sort of in that mode, we should be able to use, like, the arrow keys or something to, like, navigate through these. So then what we need is some idea of, like, what the match level is, right? So we need something that's like, in the diagram group itself, which is this thing, we need some idea of, like, what this, what this thing is going to do. So, maybe, I don't know, maybe we, like, have an actual thing that's like, oh, there's like, handmade diagram max depth. Maybe we just make this thing. To be honest, I think 60, it's just stupid. Like, it would just be unwieldy to use. So we're not going to do that. So maybe we do something like this, and we have, like, an at diagram, and then we have a, like, diagram filter depth or something. Like this. Does that make more sense? And then what we do here is we just say, well, when we're drawing these things, every time we hit, like, a begin or an end, like, we're going to have a thing that's like, past filter or something. And every time through here, we're going to set, like, past filter equal to something. And when we go to do drawing, like in any of these things, we will set that up, and we'll just won't enter this case if it's not there. Something like that. Something like that. Now, because I want this code, I don't really care how fast this code is running. I have no reason to believe it will be particularly slow. So I'm just going to make it a little easier on myself. And I'm going to put these cases at the top. So that they are processed prior to the switch statement. Although now that I think about that, we still want the diagram color thickness and text part to probably still happen. To be honest, though, no, we really don't. I mean, I do think those probably should have been reset as part of this. This should have, like, reset those anyway. I'm not sure how we want to deal with that going forward. All right, so maybe I take it back. Maybe we'll leave this in there. It's a little annoying, but I guess I'll leave it in here. So let's suppose that we actually have just a thing that's like should draw. And I go in here and I just, like, nuke these cases. So we just don't draw stuff. In that case. And like there's a phantom one here, but you know, we never implemented that. So. All right, and so whenever we hit diagram begin and we do one of these things, we need to do a computation to determine whether or not we're going to pass the filter or not. And whenever we do, like, you know, we do the begins and the ends or whatever, we need to update this past filter value to come from something that we compute. So we do stuff like, look, if we can look up in here, then whatever, like, should draw is just going to be equal to whatever the old, assuming we can look it up, is just going to be whatever the old one was. And the same would be true here, where, like, whatever we determine the, like, should we draw this thing or not is going to come from here as well. So, in a sense, like, that always happens, but we also, like, update the past filter thing. And I think, I could be very wrong about this, but I think this is actually pretty simple. So, like, this is just the past filter for this is just whatever the current state was. So we assume that children are always drawn if they should be drawn, if the parent should have been drawn. But then if, like, the filter depth is, like, if where we're at, if the diagram depth that we're currently at is, like, less than the diagram filter depth. So, like, if they were both 0, we don't do the test. If diagram filter depth is, like, 1, and we're at diagram depth 0, then at that point, we would be filtering, so we would check to see whether we would filter on this index. So the diagram index at that diagram depth would have to be equal to ours. Right? I believe. I guess technically this is supposed to be after, because if it was 0, it would be this way. So, if these are equal, then, or I should say if they're not equal, we would turn it off. Something like that. I want to say that's just sort of what it is. I'm not sure it needs to be really any more complicated than that. All right, so we'll go back over that again in a second, but I think that's roughly what we want. Yeah. So now we just need some way of actually navigating through these things. I think we could already start debugging this a little bit, because we can now go, like, make sure this code works for no filtering, right? So it should be that if with no filtering it would work. I suppose I need to start should draw at true, though. Which I think is what we want. Because otherwise things will never be drawn. Because the root has to start at true. So I think that's correct in that it's like, you know, it draws the thing. And so now we just need a way of setting it so that we can set the... And that's... I don't know what that is. This is some kind of four-coder flurry thing. Look at that. If you would like purple things to be purple, you can click on them with the right mouse button. I do not know what that does. Like, what is that? I have no idea what that's even meant to do. I feel like Ryan needs to tell us what that is supposed to do. Something. It's definitely doing something non-trivial. Like it's doing like a rectangular selection of empty space. Like, I have no idea what that does. Anyway, so if we look at the code where we've got, you know, single stepping and whatever, I guess we can do something where we say, is single stepping, like, we don't even really care, I guess, about single stepping anymore. Like, we don't need that at all, I don't think. We could just have a reset button. Okay, so that's for... We don't... Yeah, so we don't really need... We don't really need that for this, but we'll leave it on there. So this is a different thing, and that's fine. And we'll leave that in there. But I'll then do, like, a thing down here where we do, you know, label F, and we'll say, like, diagram filter. Something like that, right? And then in here I can just put in a... I guess I don't know if editable PX is the right thing. It might be. I mean, probably not, but maybe it is. I mean, my guess is it sort of is. Because, like, we can set the... Yeah, we could just have two sliders that are like, what depth do you want to be at? I mean, it's probably you probably only really want a slider for the second one. So maybe you want like a button, excuse me, for the first two or something. That are like, we want one for stepping like forwards and backward, or up and down the hierarchy. So like up and down. And those would just be like whatever that group was. This stuff here, the diagram filter depth for like if you go up, if the diagram filter is greater than 0, then you know you would do something like this. So we I don't know why that's in there. It's not even remotely right. There we go. So we just have like a value and we move it like up and down depending on which one we want to do. So we can go down to like lower levels of detail or greater levels of detail. know how this thing label f works. Is it just like %? Yeah, it looks like it. So, you know, if we just have %u kind of thing, so you can see it. So we just do like, there's the filter depth and there's the filter index at that filter depth. And this really, since I think that's right, this is actually not quite what we want. So in this case, like when we do these labels, we need to, like this part, you do want to do this, and you want to do it that way, right? It's the filter when you do the depth, it's like the depth -1. But that means that when it's at 0, you would turn it off. So I think what you really want is this. Where if the diagram filter depth is 0, you like print some other thing that's like something like that. Yeah. I don't know how this got to be something other than layout there. Probably bad autocomplete, but. So, like, in theory now, we should be able to control one of the parameters, and then I just need, like, a slider for the other one or something. So, this will allow me to, like, filter a different level of the hierarchy, but I can't step through different diagrams, right? So if you, like, imagined, like, okay, we're looking at something like that, in theory, like, you can see, and in fact, it already is sort of working. If I'm filtering out, like, that's like the first diagram on each frame. That's the first sub-diagram on each frame in theory. Doesn't look like it's quite correct, so I think we screwed it up, the filter, but that's what it would be. And then we need like a little slider here. I don't understand why these... Oh, because I put it in the wrong place. Probably that. Probably want the label and then the thing. Okay, so now if I look and I just say down, down. There we go. And you can see that it's on the thing. Perfect. All right. So I think that's all good. That seems pretty straightforward. So then maybe what I'll do is put one of these in there. And I don't actually have one of these for integers, it doesn't look like. But I could use float for it anyway. And then just map the float. Map the float to a value, right? So like if I wanted to, I can do something like this. And when we look at the depth here, I could just do something like, okay, look, if you just convert this to a U32, then that's what it is. And then we can just have like a standard slider, I guess. That's like... whichever one of these we're on. And we don't really have a maximum here, so I don't know. I guess it would just be from 0 to some very large number, right? So then we just have to make the filtering work, but I think that's roughly it. So, like, you know, you get stuck or something. You can... What is this complaining about? Oh, it doesn't like something about the way I called this function. I must have made a mistake. So here it doesn't like this. Oh, I see why. That slider isn't valid if we are below the you know. If we are below the depth. So if we now go down to one of these, you know, in theory we can now change like which one of these we're looking at. I don't know what. Oh, because this is a float still. So at this point now we just need to make sure the filter is working properly, but I believe now we're like setting the values in this thing. So, you know, if we step down, I'm just going to do some random stuff here. All right. So that's a stock diagram. So now we should be able to make it so that as this thing rolls, we like draw different stuff. And it sort of is doing something, but it's like the filter's not quite right. You see what I'm saying? Like it doesn't advance properly or something. So we just need to go debug this code, make sure that we're passing in something reasonable here. But other than that, I think that's all we really need. All right. So let's take a look at what happens here. So on the first, we always need to look to make sure that the diagram depth is within bounds, and that's fine. The depth just goes up and down as it should. That all seems fine. When we look at the diagram depth, we say, okay, whether or not we pass the filter is just whatever the previous value of should draw is, which starts out at true. So the first time down, we would just set it to true for sure. We then look at the diagram depth and see if it's less than the diagram filter depth. So let's say we set this to 1. So this is 0 the first time through. We would say, is the index that we're currently on, which is also 0, if that's not equal to whatever the filter should be, then we set the past filter value to false. Okay, so this is wrong. Should be that. Although I guess it doesn't matter, because we haven't done this yet. Otherwise, we just leave it what it should be. I suppose this actually is unnecessarily verbose, so really you could just do this. Right? I think that's all we actually need there. So anyway, first time through, right, we would set the diagram index to 0, or rather, the diagram index would be equal to 0. So if the diagram filter index is something other than that, it shouldn't draw. So it should draw to false. It will remember that for its children, right, if it pops back up. But that's all the past filter thing is doing. So we increment the diagram depth, And then, you know, let's just ignore anything that happens down there. We get into some other begins or whatever, so we do another begin. But in theory, like when we hit the diagram end for that one, it would pop back up and just look at whatever the past filter value was that it was setting, and it will reset should draw to whatever that should have been, right? Whatever it was before we went into this thing. So I suppose the problem here is that this should actually be set prior, meaning that should be set before we do anything else with it, because should draw is the value we actually are using, and the past filter thing is what will restore it to. Okay, so that was definitely wrong. I don't know that that's enough wrong, so we probably still aren't quite right, but let's just see what the behavior is now for the next round through. Okay, so there's some gunk. Let's suppose we go down a level, 2 levels. Okay, so now we're sort of working a little bit better, right? You can see us drawing the stuff, right? At level 2. If we went down one more, you can see us testing the spheres, right? So that's kind of nice. This goes up way too quickly, which is a bummer. So, like, maybe we do need something a little bit different there, but yeah, like our slider code is kind of crap, right? So I think this is all we really need. I think we're good now. That seems to be working. It was just the restoring of the stack was wrong. This is kind of garbage. The editable PX code, we need like a step value in here. You can see it's this nonsense, the DX value. So what we might want to do is something more like this. Like if you didn't specify DX, then it will do that. But otherwise, it won't. And that way, like for things like this one, we can do like, oh, you know, what's the delta X value? When you move, like, I don't know, maybe it's like 10 pixels per, or some crap like that. This is not a good UI, obviously, right? It's just a debug UI, so we don't really care. As long as we can use it, it's fine. So then when we do it here, like, that's better, right? Because I can get, like, fairly precise now, which is what I want. And so when it gets stuck, as like so, now if I go down to one of these, I should be able to, like, yeah. I don't know why that is happening. So if I go past the total number, that is somehow relevant. I'm not sure why. So I think we still have a bug. Like this doesn't make sense at filter level 1. So it looks like we still have a bug in there. Like that, that's not right. It shouldn't be like all of those things are not on diagram level 1, right? So like each one of those should have been stepping through there. So there's still some kind of a like not quite right thing in the stack processing, as I originally surmised, but then talked myself out of. So we're not quite right. So we save in past filter here what we were doing, so that we can restore it when we come back, right? Which is all this. That's all this code does at all. It's not very interesting. This seems pretty straightforward otherwise, so I'm not sure why we're getting a problem with stepping through. We look to see whether or not the diagram depth is less than the diagram filter depth. Like, that is just keeping us... That's so that we don't have to like, that we won't only just pick one child if we can draw, like, all the children of something if we want to. So that seems fine. Like, I don't see why that would cause us a problem. And the diagram filter index also looks fine. So, So, one thing I would like to do... Let's assert the diagram depth is 0 at the end. Because one thing that we don't really address here is what if there are unbalanced... Like, what if our code that syncs is wrong? Yeah. So it could be that actually just the code we're actually calling, that's like calling this, is wrong. Meaning the places in the code where we have a diagram begin don't match. And that would do it, right? So let's just double check to make sure that that is a thing, because it might not be a thing. And then we would have a problem. So here's the thing where we've got a diagram begin, and there's a diagram end, and that's fine. Here's the thing where we've got a begin for move entity, so that means there has to be one like all the way down at the bottom, and there is, right? Here's one inside the walk here, and it's got an end as well. So they look balanced though, right? Those all look pretty balanced to me. So, yeah, I'm not sure what happened there. Seems like that should be pretty straightforward. So let's take a look at what's going on in there. Because maybe that would give us some insight into what the bug is in this particular routine. I think we're almost done with what we needed for stepping through and seeing what happened, right? And then we can, add the code that we need. So what is the value? Because we'll know whether it's an underflow or an overflow, which would be good. So it's like there's just one unclosed one of these, apparently, right? And I guess we don't know which one it is, but we actually could put in something pretty, it would be pretty simple for us to figure out, like, where this ended, I guess. But, so we know that, like, we've got just one open that didn't get closed. Right? One begin that didn't end. Because the depth is 1. If we had an additional end, the diagram depth would have been, like, 42, 4.2 billion or whatever. It would have been that. Right? 4.3 billion. So we know that we've got an open that doesn't get closed somehow. But I'm not sure how that's possible given what we're actually doing, since we just looked and saw that that really wasn't the case. Maybe what's happening is we're breaking out of that loop. Yeah. So it's just that right there, right? So I don't know how we want to deal with that. There's a couple different ways. One is we can use like a constructor-destructor pair to like force this to be done. I tend not to like those kind of things very much, right? And the reason that I don't really love those kind of things is they create kind of like hidden code that's hard to understand. Like you had to just know that like, okay, there was like a thing that would automatically like clean up the diagram end code when we broke out of the loop because it's got a destructor that you can't see. So I'm not sure that's the best idea because, it seems like we could pretty easily just allow this code to finish instead, and it wouldn't really be a huge deal. So let me think about how I want that to work, but I don't know that I'd be disinclined to like wrap it in the thing. I don't love that idea, so I think I might just not do that. Excuse me. So effectively what we're doing here is we're checking to see whether this cell is already in the target cell. And if it is, we just stop looking. That's all this is like an early out, right? So the first thing to note here is it's not really it's not really even, it's not really even something that it's not even really something that we want to have happen, because when it breaks out of here, it won't even draw this diagram. So what was the point of some of this stuff? We would never see the last box either if we did want to like re-enable this particular case to run. So you can see why I'm not thrilled about this. So maybe what I do is I just say, look, there's going to be a like a found best in here, right? And maybe what we do is we just say like, okay, found best equals true in this case. That way we can still run as much of this as we want. We can also say if found best here, so we don't have to do this. But that way we exit the loop at a controlled point, which I think is just more important to me at this point in the thing, right? So I would prefer that to the alternative. But you could do it either way. If you did, we have done things before where we did like a constructor-destructor pair to mark begins and ends of loops. So, if that's something you want to do, I'm not going to get mad. But in this particular case, I didn't like that. I didn't really like that solution, so yeah, I'm less inclined. All right, so back to what we were trying to debug before. Well, that's interesting. There is something that happens in that case, in that particular case. Oops. I don't know how that got there. There are no other breakout loops in here. So we have one other bug, right? Like we have a bug of a different kind, because I don't recall seeing any other way that you could break out of anything without completing your diagram. Maybe I'm wrong. Maybe I'm missing something. But at that point, you look at what's happening in here. There's no real way to jump out of this anymore, and the rest of the things aren't loops. So I don't know. I don't know how we would get that result. So that's still troubling, right? Let's see if we can make it happen in debug mode so we can see what kind of a begin-end pairing we have. We should turn off lighting one of these days, or just fix it so that it's not so slow. Because debug mode actually runs totally fine in a lot of cases. Although I suppose with collision detecting being completely unoptimized, that we would have to do as well, which is what we're working on. So I suppose we don't really have that luxury at the end of the day. Too bad. So I'm not really doing anything here. I'm just seeing if I can make make a trigger, like make it trigger that path where the begin and end don't balance while in debug mode, so I can inspect easier. Not looking good. In release mode, it's pretty easy to trigger. If only we could ever step through anything. You know, imagine a world where, like, someone made a debugger where you could actually step through release mode code and inspect anything, ever. How much easier this would all be. But, of course, you can't, because the debug information that they create is so bad that you can't ever find it out. R15D. What the heck was diagram depth? It's a U32. All right. Well. Same problem. So it feels like breaking out. Was there another break statement or something that I missed? I don't think so. So again, not really sure how that is managing to happen. There isn't like a return, you know, in here. So that's a puzzler. I don't know how it's managing to do that. I do not know. And with completely unoptimized, it may be very difficult for me to actually like step through and see how it's able to generate that result. You know, it could be this. In fact, that is what it is. I suppose I do have to do that. Which is to say that once you do set capture, it won't record anymore. So the diagram end won't work. I suppose we could have... Well, not really. So that's all that was. I guess that one's not that hard to find, so it's okay. Question remains, though, why is our filter broken? It could be that our filter isn't really that broken, but I think it still is. So now we just need to go fix this part. And so at least now that works properly. Right? So now we can step through the moves that occurred, right? Pretty easily. And that's nice. So we can look and see, like, okay, so we know that, like, this one right here is the one where we had the issue. So the one right before it, if we look, let me go down one level. Well, that doesn't work very well, does it? So it looks like we're able to step on the top level, but when we go down to the next level down, I can't really step through what all of these things are. Right? But I'm not sure why. So we have a little bit more work to do here. We can step through the top level. So we can see, like, everything that happens leading up to it, but we just can't get down one level from there. But I thought we were supposed to, because we definitely have one more level of information, don't we? Like, inside, like, each time through here, there's a begin and end, right? So each frame, we've got one here, and each cell of the voxel, we've got one here. So we should at least be able to step on level 1 and 2. But for some reason, we can't. So again, still a bug in the filtering code, presumably, where for some reason we're not filtering correctly at the level below. It's like no matter what we set it to, it only shows us the first step or something. Why would that be? Why would that be? There's got to be something here that's counterintuitive that makes it so that we can't, when we descend twice, so when this code path runs twice instead of once, right? So you hit the first begin, it's a frame. Oh, excuse me. You do a diagram index increment. And yes, I do know what the problem is. When you do a diagram index increment, you also have to clear whatever is at the depth that you're going to move into, because otherwise it wouldn't work. So basically, when you go to do this, right, you need to do, every time you end the diagram index at that depth has to get set back to 0, right? Because otherwise, it'll just keep going up forever, and you'll never... Yeah, so on the first one, we probably could have done it. But then, by the time you increment the top guy to a certain number, you've incremented the lower indices too far. And they don't get reset, right? So now, if I do, like, this, or whatever, go back to the one I was on... I believe that's the one I wanted to see. Second to last one. I go down one level. I should now, yeah. I should be able to, like, just step through all of these and see what the heck it was. Right? So now we can watch the collision solver, like, work over time. We can start at 0. So, you know, this is where it started on this frame. It looked through a bunch of these and it found where it wanted to place the thing eventually, you know, whichever one that was. We'll have to look and see which one it was. We go down, oops, we go up, and we go to the next diagram. This is the one where it fails, basically. And we look at what we're actually seeing here. You can see that where it is placed, it finds them all to be red, right? So if I actually look carefully where that is, right? It's like this one right here. If I go up to the previous frame, it sure doesn't seem to be producing, like, you can see that it doesn't think that those green ones, it never even has one on the front row there where those green ones are red. Right? And you can see, like, it's true about the shift. So I think that actually is what's happening. What that suggests to me So for the simulation centers, there is some kind of a like, so I think what that suggests to me is we just want these things to be on even movement levels. So, you know, the unembed code would solve this problem, but I don't think we want to have this problem in the first place. So, like, when we look at the motion displacement size, I think what we want to do is make that be, you know, the chunk dimension for the world should be related to that. You know what I mean? And so when we're, like, setting the chunk dim in meters, you know, this stuff, right? The fundamental unit should be a multiple, like, what we really want to do is make these things be, like, well-defined relative to each other. So the motion displacement size and the fundamental unit are, like, not similar values to each other. And I think that is where we're getting this problem then, as a result. If this were 1.5, we wouldn't have a problem. If it were 1. So 0.125 times, you know, 12 or 11. So 1.375 would be fine, right? That would work. So a slightly different dimension for everything would presumably work okay. Although, as I say that, you can see that it actually didn't, right? But I believe that if the actual way that things move, although I guess so, you know what, I just realized this may be pointless. We may not always move a even chunk amount for simulation centers. In fact, we know that didn't happen because when we looked at the simulation centers, they had, like, garbage in the XYZ. So, like, yeah, simulation centers not moving by a constant amount each time is definitely an issue. So, like, I don't know what we want to do about that. I do think we want to make sure that this is fixed. I don't think we want to allow that to happen, where the voxel slides relative to things. But I'm not sure what the best way to solve that would be. Thinking it through, I want to go look and see how we're actually doing that. Like, how does this thing decide those values? Because I don't know. Like, how does it do the simulation center in the first place? Because I don't know. You can see here it's like, oh, like, map into chunk space, get the simulation center for this room. You know? I assume that's, like, the only real place that simulation center is set. Besides the initial setting, right? So really, our problem here is just that the simulation center itself is never rounded to the actual fundamental values, which it should be. So that's, I think, all we would need, right? So, like, if you imagined something like this, this simulation center is, like, hey, here's the offset, right? It's going to do a map in a chunk space of this. If you then took the simulation center here and you just like zeroed the XYZ, you know what I mean? Or you rounded the simulation center. I got to think about this a little. But just like for numerical accuracy purposes, I think you really want to do that. I mean, there's another way you could do it, which is just to offset the thing. And maybe that's just fine. But it seems like you would like this to be correct. So you'd like the simulation center to always be snapped to a fundamental unit boundary, right? And I guess when I think about it, this is actually fine because you don't really care what this fundamental unit is, really. You only care that the simulation center is always snapped to the motion unit, right? So really, that would be fine. As long as it's always snapped to 0.125. So in other words, this thing here, if you just always insisted, like literally you just did this, right? Where the simulation center is always set to like some kind of thing where you do the same kind of like recentering as you were doing before. In theory, that would always put you at a value truncated that. Now, it assumes you started there, so that may not quite be right. But basically, if you just do that one offset so that now you're always aligned to that voxel, now I would argue you won't have that particular bug, right? That particular bug. You may have other ones. And of course, we didn't. Not 100% conclusive, but we didn't. So I think that's a good start, but, you know, I don't know. Looks like we have one here that's an issue, though, right? Looks like a detected one here. And that has nothing to do with it, because that's not a camera move, right? The camera doesn't move on that boundary. So you look here, we can say, hey, what happened there exactly? So somehow it decided it needed to stop this one, but I don't know why. All right, this is the one it actually needed to stop, sorry. So somehow it decided this one was colliding, but what was it colliding with? There's nothing there. That just seems straight up buggy, right? Like there's nothing there for it to collide with in the first place. All of those are non-colliding. So it just like return collision for all of those, but there's nothing there, right? So that just looks like straight up buggy code for the collider. So that's a good thing to debug as well. So I think this might actually be something I want to do. So we kind of want like a call that's like align to movement grid, align to movement voxel or something, right? Where this will happen, like something like this, and we probably need Seldim in here because we use it again, right? So this kind of needs to be something that also exists in here. So, you know, there's that. But to a first approximation, it's this. So this way, when we come through here, we can say like, well, simulation center equals align the thing, right? And it returns a v3. And voxel starting corner. Will come from calling it, and then it just needs to be something exposed to the outside world. So I think that's fine. I'm not sure, like, again, it kind of needs to be something. There's this part here where it's like setting the simulation center to something. And so that's a little bit troubling because, you know, we need this to be correct and it's not going to be. And so what we really want here is for this to be ideally we would like this to be set later, right? So ideally what we would like this to be is for this to be just like always set to all zeros or something, and then it moves to the correct location. So this is kind of annoying because it's hard to reset this properly. I'm also not entirely sure, like this part here, right? So I guess that's just going to work now that I think about it, because it's always going to be set to 0 anyway. So I guess that's okay. It's not the best thing in the world, but it's okay. So I think that's okay for now. Maybe we'll put off to next weekend. Debugging the, we have like a collision detection problem there, right? So in here we had a problem where we had the glove in a place where it could totally move just fine, but the collision detector said like, no, it couldn't. And there's really not an explanation for this because there was nowhere for it to go. So it doesn't make sense. I mean, nothing for it to collide with. So it doesn't make a lot of sense. Why would we be seeing that? Anyway, again, though, getting much closer now to solid. And I like the fact that we now have really good tracing in there, so I can step through and watch and see what the heck it's doing, because that's really the only way to debug these things. There's no other way to do it, right? So you can see that if you play around with it for a while, you get into these situations again. And here, I assume this is exactly the same bug, where it's just maybe our sphere collision detector, for example, is just buggy. Like it's not very good. Because again, like the other time too, it wasn't even on a case where the camera moved, so it wasn't even something that could really be explained away in that context, right? Yeah, and I mean that's just floating in the middle of nowhere. Like there's nothing for it to touch. So it looks like our sphere tester like has some kind of a bad, or just some other aspect of the system, right? Where it's testing these and thinking they're failing. So that's next week. But otherwise, I think we're good. I think we are now good. Right. So I like the fact that we fixed the camera thing. I like the fact that we're now rounded the voxel properly. We have a bug in the sphere collision detection, or just the way that it sets the values. So it could be that the collision detector is returning the correct value. And in fact, you know what? We can check that really easily. When we do the collide thing, so when we do this collides part, we could just draw that in here, right, as well. So in shapes collide, when we do this stuff, we know what the result is for colliding and not... Oh, well, I guess we only draw it if it collides. Oh, okay. So the fact that we saw those spheres is just wrong. So actually, we already know. We already know that it's wrong. It would seem, right? So of course it's hard to get it to trigger, which is what you'd expect, you know, if it's some kind of subtle problem in our collision detector, right? You can't just... There we go. So you kind of have to wait a little while to get it to go. But what it looked like in that routine to me, very, you know, pretty clearly, right, is that if we're diagramming and the result is that we collided, then we draw it. But if it's not colliding, then it never will. So in fact, this is like meaningless, right? We never actually do that. We only come in here and draw it if that's the case. So what that would suggest is that when we look at, you know, wherever this thing ended up, right there, the fact that it draws all of these spheres is just blatantly wrong. There are two that look like they collide, the bottom two, but those top ones, there's nothing for them to collide with. Like, there's nothing for them to touch, right? So that's just like, we got a bug in that, which is, you know, and what's really kind of strange about that, in fact, is that there's supposed to be a secondary thing that we draw here, right? Meaning if you look at this code, you can see that it always draws like two spheres, a sphere in a box, or two boxes. Now we know it won't be two boxes because one of them's a sphere. So we know that it will be this set. Furthermore, there shouldn't be any spheres. I don't know if there's any other spheres in the entire game right now other than the glove. So we pretty much know it's these two cases. And furthermore, we know that when we call this code, we always pass the mover and then the test. So we know the mover, which is A, is a sphere. And we know that B is presumably not. So we know that this is the code that we're running, and there should be a box, right? This box B. So somehow, and we don't know how, there is supposedly a box that we are colliding with that is here. That's what that... Oh, well, no, that line might not be that. I shouldn't say that. We don't actually know what that line is. But, like, there's the line. So there's a box here that we're colliding with, and, like, there is no such box. And when you draw it, like, because we are drawing the box, it's not there. Like, we don't see any box show up. You know? You know, maybe it's like a very tiny little invisible box. I don't know. So that's particularly odd. We do record what box we think it is, like this box B thing here, right? So one thing we might do is we might want to we might want to dump the data for whichever diagram thing we're on in here or something, so that we can see what the actual value of B is, because it's like, what is this box? It's like a phantom bug box, right? And we just have no idea. We don't know where this phantom bug box is coming from. It's some magical mystery box, like the Magical Mystery Tour, that doesn't actually exist there, right? So I don't know. That's going to be a puzzler. That's going to be a puzzler for next time. We have no idea what it is. And I guess we'll leave it for next time. Any questions? But we're now quite sure, right? Like, we're now quite sure what's going on. But, like, something that we can't see, like the size is 0 or infinite or something, right? So... yeah, it could be, like, very large. It could be, like, a huge box that's so big you can't see it, that only existed on that one frame for some reason. I mean, it can't be the hero's head, I don't think, because we disabled that collision box, right? So this would... that would do it, but it ain't there, right? So that's why we're not considering that possibility. You cannot move diagonally in this game, no. You can only move in the cardinal directions. Yeah, we definitely can write that. It's just we just need to add in our debug display something to do that, which is what I was suggesting we do last time, just so we can see what the value is of that thing. The other thing that we probably want to do is, like, be able to tag the entity or something. Like, if this entity, when we do collides at P and we loop over the entities, if we had a thing that basically said, like, oh, pass a, like each entity gets tagged with, like, which generator function generated it, then we can also print out, like, what type of entity it was, right? Like, who generated this entity, you know? And that would help us to determine, like, what kind of a thing it collided with as well. But yeah, I have no idea where that box is coming with. All right. Yeah, refinement is still running. It could be that the tunneling was happening because of the camera movement thing too, right? Which we now fixed. Yeah, the entity cache system is still in. This is all going through the entity cache system. I don't think the entity cache system could explain this, though, because we're drawing what we think. So let's suppose there was a phantom entity on that frame that the cache system erroneously said was there. We should still have seen it drawn, right? So the fact that we don't see the thing that it's supposed to collide with suggests that it's more of like a garbage value problem, because somehow there was something for it to collide with that we don't then draw, which doesn't make a whole lot of sense, right? No, I don't think the mystery box pushed into the wall. I think that was probably the camera changing when you hop across the threshold. It would change, be embedded, and then be able to go through it because of the tunneling, right? That's what I think. That'd be my guess anyway. So I don't think this particular part has anything to do with the camera moving. The reason I say that is it seemed like I was able to get it to happen without being at a camera threshold at all. Now maybe that's false, but I thought that's what was able to happen, because I thought we were able to do it just in this room without the hero moving out of the room. I thought. I could be wrong about that. But, I mean, look, right? Like, we never changed the camera, and it did it. So it seems like it's just one of these things that, like, is some kind of garbage value problem where we're just, like, doing something totally wrong, like, you know, misattributing the location of something. But, like, you know, we weren't moving the camera, and it just recorded collisions for all 4 of those points, even though none of those points are colliding, right? So, like, somehow, just stationarily, you get in a situation where it suddenly thinks a bunch of things collide, and they definitely don't. Now, it could just be, like, this routine is just buggy. Like, it could be that, like, this math is wrong in a subtle way or something, right? So, it's not necessarily the case that's what's going on. But, again, this is the part that really is confusing me. Unless it actually is drawing this thing somewhere, which maybe it is. I mean, I guess we didn't actually try to determine that there's nowhere else for it to do this, but you saw what I mean, right? Like, we're not even moving. The game camera is staying stationary this entire time, and we were able to get it to happen. So I don't think it's required. It does seem, however, like I had to move out of where I was, though, slightly. Like, I'm not able to get it to happen just in here, but when I moved up here, I was able to get it to happen. Of course, that may just be random luck. Again, this doesn't trigger very often, right? It seems to take thousands of frames to get it to happen. So it's kind of one of those unpredictable bugs where you're like, I can't really make generalizations about when it does and doesn't happen because it's so rare that, like, who knows what the, you know, what the actual thing that precipitated the bug was. But you definitely saw it happen. We just don't know how to make it happen more reliably than that, unfortunately. No, post-stream I really only try to take only questions that are on topic. Pre-stream you can ask general questions because we haven't started yet. Not that we always really adhere to that rule, but we should. Well, this is a very hard bug to reproduce, apparently. There we go. So, you know, you can see it light up boxes as they get hit, right? You see them lighting up the boxes that it hits. And then, oh. My LED strip just got wanked. That was bad. I don't know what happened there. So you can see here, like, when we hit this case, who is the box that is getting hit? Like, nothing in the entire world seems to be highlighted white. Right? It's just not there. So it's not like a very large box. It's not an like some random entity over here is getting hit. Like, there's nothing keyed. The entire time, nothing is keyed. Right? So I don't know what this could be colliding with because it doesn't actually show. Now, just to underscore this point, if you imagine, like, here, right, what you can see is every time you hit a collider, you see, like, the wall light up. That's the thing it hit, right? So you can see that every time you look at one of those sphere hits, it shows you, and furthermore, it shows you the direction it's in, right? So, like, that little thing there is like, oh, it's over here, right? The little white line. So, like, that's what I'm talking about when I say we've got a bug, is that, like, it's pretty clear this is a nonsense collision. So the result that we're getting when we think that this thing has collided, it thinks it's colliding with something, but it's not even a bug in this math. It's a bug in the input to the function somehow, because the thing that we supposedly collided with does not exist. Right? It does not exist. And so we don't know. And it's pointing, right? It's pointing somewhere. They're pointing to different things even. Like, look at that. Like, it says we collided with two things, one there and one there, right? But we didn't. Like, we definitely didn't. The line going off to the left is where the move was supposed to be going towards, I think, right? So that's like, oh, you know, we were trying to go this direction on this frame. It wanted to head over this direction to here. Is all that is, I believe. Don't quote me on that, but I believe that's what's happening. The direction vectors aren't normalized. It's literally just a line to the center of the other thing. So, like, it thinks the thing we collided with, it thinks is centered there. And centered is the wrong term here, I guess. You know, there's another possibility, which is that the diagramming system is broken. Like, maybe this is a valid box and it's drawing it wrong in some cases or something. I mean, I don't know exactly why that would be, but, like, you know, it's not entirely out of the question. There is one thing that's a little weird, so let's think about this for a second. So let's take a case where something is colliding and it draws it correctly, like there or something. It's true that the get center function, like, something is weird, right? Because that is the center of the sphere. It is the closest point on the box. Okay, that is what it's doing. Never mind. So that is what it was supposed to do. That's fine. So yeah, so, like, we don't know whether it's a box or a sphere intersection, I guess. Which maybe we should draw so we can see it. But yeah, like, if you look there, it's like, oh yeah, what's the closest point on the box, quote unquote? And it's like there. Like, okay, so it's the closest point on the box is there for what box? There's no box at all that could possibly have that be the closest point, right? So not only is it not drawing this box, supposed box, so we don't know what the heck the box input is, but it also, yeah, doesn't have that property. Now, it's possible that we created, like, a phantom box that's inverted, and a phantom box that's inverted maybe would, like, suppose we pass it, we come in here, and we look at, like, do we have a has volume for other things? I don't think we do. But if we look, we could see in, like, the rectangle code, which I guess is in here. I don't actually know. So yeah, it's called has area here, I guess. But we could check to see if this thing has area, right? So we could do something like, oh, if we collided, and we go in here and we say, like, oh, we collided with a box, right? So we're in one of these two cases, and we just say, like, look, let's just assert that it has area. So in this case, it's A that is the box, and in the other case, it was B. We could just see, like, is this some weird, like, inverted box? But even that should draw. So I don't think that would be the case, but I don't know. Evidently not. So this might have something to do with it, right? This might have something to do with it. What? Oh, those are little tiny pictures of step into. Interesting. So let's just see who these people are who don't have any area. So, like, here's a supposed box, right? Yeah, so there are things that, like, I guess are going into the collision detection system that have no area. That's disturbing. That's That's kind of disturbing. So, wait a minute. Are we just, like, setting people who have no collision volume? Are we saying that they... Does this just not filter on something that should be filtered on? That may be what's going on here. Maybe we don't have a bug after... I mean, we have a bug, but... So do we not have a, like, thing for participating in collision or not? It looks like we don't. So really, yeah, I mean, this is not very good. So maybe, actually, this is our entire problem. Maybe, actually, this code, when we do shapes collide, has to have volume, right? So yeah, let's just do that. So when we do move entity in here, I think we just, yeah, I mean, like, I think we just check the corners. Only for things like for that actually have collision volumes. I guess we just assumed that was happening, but it definitely wasn't. So basically, if the collision volume is not valid, then we just don't test the thing. We should probably just have a flag for that, but you know, we didn't. So that's probably just all it was. I guess we actually have entities in there that are stuck, that are set to, like, not color, just fake things, like, you know, markup things we used or whatever. I'm not sure that's actually what it was, but that was definitely a problem. Because we don't want to be processing those anyway. Right? We don't want to be processing those anyway. All right, so I don't know that we actually fixed the bug. I think next week we'll have to look for it in earnest. But at least we now know that we're not, like, checking a bunch of things that weren't supposed to be colliders, which may have caused us a lot of problems, right? So. All right. All right. I'm going to call it. That all seems good. That all seems good. All right, folks. So I'm going to wrap it up. Thank you, everyone, for joining me. If you do, by the way, our Kickstarter for Meow the Infinite is still going. It's actually only halfway through. It did really well this time, so it's doing excellent, but it's only about halfway through. If you're interested in a cool graphic novel series, I would highly, highly suggest checking out our Kickstarter for Meow the Infinite Book 2. You can get Book 1 as well. I will post a link into the chat, but I think there's also like a link at the bottom of the Twitch page thing, right? Like the little, like, if you're on a platform where Twitch shows the things below the video, whatever you want to call those. But I will pack those in there. Yeah, meows backwards. I have to flip the camera. So remember, people didn't like that I faced away from the from the programming. So the camera's flipped when it's tiny. If I switch to big, then it's right. You know what I mean? But in tiny, I have to be flipped so that I point right. So, so anyway, check that out if you get a chance. It's pretty cool. And I will be back here next week for looking at if this bug still exists or not. We may have just fixed it, but I would like to go also see, maybe like look at what those entities were, like why we have entities with zero collision volumes. Are they actually supposed to be there? They probably are. They're probably just like placeholder entities for things that are like not, that are like logic things or whatever. So they might be valid, but I don't want to assume they're valid without actually looking at them and seeing why we're creating them in the first place. Make sure they're not just like garbage that gets generated by the world generator incorrectly, right? So I would like to take a look at that and have a better understanding of why we had those entities there in the first place. So we'll do that. But I think that's about it. Thank you for joining me. Please check out our Kickstarter if you get a chance, and I'll be back here next week to take a look at that stuff and maybe start to do just like a spatial partition for our collision detector, because it's still really slow because it checks all the entities in the world for every one of those collisions. It's amazing that it runs as fast as it does. It's so weird how fast computers are. But we need to fix that because it should be basically instant, but right now it's very slow. So we'll do that next week, and hope to see you back here for that. Until then, I do have more stuff, I guess, coming out this week. So there'll be some live streams this week. There's a cryptocurrency interview happening. If you've been following that series of cryptocurrency interviews, that'll be happening. I have a very special thing happening this Thursday that I think will be very interesting. I don't know how it'll go, but me and Jonas Kiratzis, from the person who wrote the Talos Principle. I don't know if you ever played that game. He's a writer that game companies like hire to write the stories for their games and that sort of stuff, right? He and I are doing a Babylon 5 Season 1 recap because he's like a huge Babylon 5 fan. And I'd never seen it before. And I just started watching it. And so every time I finish a season, we're just going to do like a live stream where we talk about the season. Right? So this Thursday, there'll be a live stream too with me and Jonas Kiratzis about that. I apologize if I pronounced that name wrong. My Greek pronunciation sucks. So for any Greek folks out there listening, I apologize for pronouncing his name wrong. I'm sure Kiratzis in Greek is pronounced different than that, but actually, so is Jonas probably. I don't know. I don't know the pronunciations of these things. You can sort of hear it, but like if you're not a native speaker, you can't really hear it right, you know? So you tend to butcher it. But anyway, point being, you know who I'm talking about. He also made a bunch of cool games like The Sea Will Claim Everything, and he does like a audio, like a radio play thing too. I don't know. A lot of people out there probably know who he is already. But point being, we're going to talk about it. And I'm looking forward to that because I think that'll be a lot of fun too. So we have a bunch of live stream stuff happening during the week as well. But I'll be back here for Handmade Hero on Sunday as usual the following week. So until then, everyone, please check out the Kickstarter. And I'll see you on Twitter, I guess. And now I'll go look for someone to raid.